Intersection and development of surface. We're going to solve this question as shown, where it's a cylinder which is intersected by a triangular based prism. Like before, we're going to have to locate the piercing points, and these piercing points will line up to create the line of intersection. Now notice that we're dealing with a cylinder, so the lines may be curved. Where do we begin? We're going to use the horizontal cutting planes method. So we're going to take random cuts through the solids, both the prism and the cylinder, which are going to create 4 piercing points, 2 on the front and 2 on the back. And the more cuts we take, the greater the accuracy. We begin by drawing an XY line. We then draw the outline of the cylinder in elevation. We then draw a 45-degree construction line. This will be used to find the end view and the plan. We now draw in the prism in elevation. After creating the prism in the elevation, we will project across our height from the elevation to the end view. Also, we will project down our lines from the elevation to the plan. The line from elevation to the end view is going to give us our height line for the end view. Likewise, the lines from the elevation to the plan are going to give us the width of the circle in plan. Now we project down both points of our prism to the plan. This will give us the total width of the prism in plan. Also, we project across our line from the elevation to the plan. Also, we will project across our height line from the lowest point of our prism across to the end view. Now we can draw the outline of the intersecting solids in plan, and we project across the total width from plan to the 45-degree construction line, which will create the total width in the end view. As we have the height line from the end view, which was given to us by the elevation, we can draw in heavy. Now we take our first horizontal cut, as seen by the purple line. This purple line cuts the prism in 2 places, which is here and here. These points will be dropped from elevation as shown to plan and create 4 points. These points will be rotated from plan to the end view, and these will create piercing points like here and here. Now we're going to take a second horizontal cut. This is indicated by the red line. Again, like before, the red line will intersect the prism in points here and here, and like before, we will drop these points from elevation to plan to locate 4 more intersecting points. These points are then rotated from plan to the end view and created another 4 piercing points. like so and so, 2 at each side. And like before, again, we'll take a third cutting plane. As you can see, the blue line intersects triangular base prism here and here. And like before, we will take these intersecting points and drop them to the plan, like so, and create 4 more points. And yet again, we rotate these points from plan across to the 45-degree construction line and up to the end view. This gives us 3 piercing points. These piercing points can be joined together to create the line of intersection. Note, as said before, as we are dealing with a curved surface, as you can see, this is a cylinder, this is not going to be a straight line of intersection. So, thanks to the elevation and the plan, we can now locate the position of the prism in the end view. It is here and here. Now, first of all, we need to locate where the base of the prism here intersects the cylinder. This is found by the blue line in plan, which is rotated up to the end view. As we know from the question, this is horizontally across till it meets the cylinder. So we can draw this in heavy till it meets the blue line, which creates the base of the prism. Now we have 6 piercing points. 3 here and 3 here. Likewise, we have 3 on the other side of the solid. Now, to locate the line of intersection, we need to join up these 3 points. As noticed in question, we are dealing with a cylinder, so the surface is going to be curved. Therefore, the line of intersection is also curved, like so. We will remove away the construction lines to make it easier to see the answer. And so, there's the question solved.